Structurally Equivalent Atoms by Gracie Mooney. Today's objective is to learn how to recognize structurally equivalent atoms in a molecular structure. So, let's dissect what this means. Basically, structurally equivalent atoms in a structure are just isomers. This means that the molecules are the same as far as the number of atoms of each element, but they have different arrangements. In this video, I will teach you about the bonding patterns of isomers and how this relates to identifying the similarities between the isomers. We will also look at how the different arrangements allow us to identify different types of isomers. Looking at the image to the right, we can see how each structure has the same number of each element, but is simply rearranged differently, giving the different structures their own traits and characteristics. There are three different types of isomers, and they can be identified through their bonding patterns and structures. There are structural isomers, stereoisomers, and geometric isomers. Structural isomers can be identified by the way the atoms connect to form different functional groups. Stereoisomers will have the same atoms and bonding patterns, but take up different arrangements. Geometric isomers are also known as configurational isomers, and they are also a subgroup of stereoisomers. When looking at the chart to the right, we can see the different way each type of isomer arranges itself. Structural isomers are arranged in chains, where stereoisomers have groups that branch off a central atom or element. Butane and isobutane are a simple example of isomers. They have the same number of carbons and hydrogens, but they have different structural formations. This makes them structural isomers. Referring to the image, we can see that butane has a chain structure, and isobutane has a chain and a group that branches off. The two molecules have different melting points, boiling points, and density, but are comprised of the same elements. In conclusion, isomers are like building blocks. You can use the same set of blocks to build different structures. This is how isomers work. They have the same number of atoms and the same molecular formula, but they have different structures that can be identified when looking at the three-dimensional structure of the configuration. Knowing the different types of isomers and how they arrange themselves will help to identify these structures and understand the difference in their characteristics.